Hello, everybody. Welcome to our session on introducing application self-service with networking and security and vRealize automation with NSX. I'm Andrew Voltmer. I'm a product manager for the NSX product, and this is Becky Smith. She is a senior product line manager on the VRA product. And so the two of us work together to produce a joint solution of NSX plus VRA so that you are able to automate networking and security as part of your SDDC. So today what we're going to do is we're going to talk about sort of what is the reason for doing this, the benefits to you as a customer. We'll talk about a couple use cases, and then we're going to do a demo. If you guys want it, anybody want a demo? Yeah? Okay. Who wants a live demo? Okay, cool. Who wants Becky to do the live demo?
That's the plan.
All right, so Becky's going to do the live demo. It's going to be VRA 7. Speaking of futures, so VRA 7 is not GA yet, but it has been announced. So we'll be covering a little bit about stuff that's in the future. Most of this stuff is about what is shipping today, but there'll be a little bit on, obviously the demo will be of VRA 7. Okay, so classic slides I'm sure you've seen many times before. IT efficiency and time. Virtualization brought you efficiencies that you didn't see before when VMware introduces compute virtualization. It basically allowed you to get things done much faster, but it's still not as fast as it could be because just compute virtualization is not enough. So with NSX and VRA, we bring you a complete story of automation of your virtual infrastructure, which includes not just compute virtualization, but networking and security virtualization. So we really improve the situation through the use of these cloud management tools. And we can drop the time that it takes to deliver applications from days or months, in some cases, down to minutes. And that's part of what we'll demo. So the integration between our two products is interesting because you have, on one hand, you have the application consumer. These are the cloud users. And they don't really care about infrastructure. They just need their app when they need their app, whether or not they're developers or other IT application staff. And they need it with more than just the VM. They need the storage, they need the networking, and usually they don't really care about the security, but somebody does, so they need security. Now down at the bottom you have your infrastructure people. You have your compute admin, your network admin, and your security admin, and they have different goals. And all these people can achieve what they need with this joint solution. So your network admins can make sure they provide the right network connectivity. Your security admins make sure the right firewalling. And obviously, the compute admins deliver the right virtual machine to the user, whether or not it's a Linux or a Windows machine or something like that. So, bit of an agenda, software-defined data center, brief overview of that. Many of you, I'm sure, have heard a bit of it in the past. I'll talk a little bit about NSX. It might be a refresher if you've been to other NSX sessions. Then we'll talk about VRA, and then ultimately on to the demo. Okay, so software-defined data center. Ultimately, what this means to me, I mean, this is kind of a buzzword, but what it means to me is that you can use software controls to build your entire infrastructure. So it's the ability to use an API or a CLI or a GUI to automate the process of creating an entire infrastructure. So it's not just the compute, but it's the compute, the network, and the storage to produce a complete application in a programmatic way. So NSX, for example, is an API-driven product in many ways. It uses API calls to create logical switches and logical routers, and VRA can make those calls through the orchestrator to automate the process in the SDDC. And we do this for both public clouds as well as private clouds, and ultimately the hybrid situation. So with the automation process, instead of the traditional do a little work, wait for somebody, do a little work, wait for somebody, we can reduce all that down ultimately to a much shorter period of time instead of the classic slow-moving physical infrastructure, hardware-defined data center model. Okay, so this is sort of the complete view of, like I kind of call it the VMware stack. You have your physical infrastructure at the bottom, whether or not it's compute, network, or storage. You have your virtualized infrastructure with ESX, NSX, and maybe vSAN. Then you have your cloud management platform. So VRA is your cloud management solution that does automation, and then you have VR Ops and VR Business is what we're calling it. I always call it VRB as a cloud management, business management tool. And all these things are extensible as well, so you can modify any of these products to do what you need in your unique environment. Okay, so what we're doing here in the SDDC is we take the ESX infrastructure, we take the NSX infrastructure, and we add VRA, and we can get down to zero-touch, one-button deployment of complete applications. And particularly with VRA 7, we've integrated all the app designer stuff into the blueprint system so that you have a complete view, not just of your infrastructure, but of your actual application that gets auto-deployed in that zero-touch deployment system. Okay, so a bit on NSX. Who's been to an NSX session before? Okay, so this might be a bit of a repeat, that I'm going to go over sort of how does the network hypervisor work. So you take your network, what we call a network underlay. So this is any IP-based network fabric. It can be based on any vendor you want, Cisco, Dell, HP, Brocade, Juniper, doesn't matter to NSX. As long as there's IP connectivity to your hypervisors or your hosts, we can then form what is called the network hypervisor. So we insert a virtual switch into the kernel of the ESX system. It's a VIB, and that collectively will, between all the hosts, will form this abstraction layer, which is the network hypervisor. And then on top of that, we can build what we call logical switches, logical routers, logical firewalling, and logical load balancing, all software-based constructs to deliver what you used to have to configure manually in the hardware underlay using hardware-based products. Now you can do through software through either API calls or click of the GUI kind of actions. So it's very flexible because when you layer on top of that a VRA solution, you can automate the entire process to deliver all this infrastructure. So NSX, generally, we give you a management API, REST-based, and we provide all these different virtualized constructs, switching, routing, firewalling, policies, groups, and tagging, particularly security policy, load balancing, VPN, and then physical to virtual connectivity through our top-of-rack integrations. So here's the sort of the quintessential app that we always show. It's a three-tiered application. It's got a web tier, and an app tier, and a database tier. And without NSX, you don't get much more than just attaching the virtual machine, spinning up a VM. And the challenge there is without NSX is you still have to have all these other components, like each of the different tiers, the web tier switch, the app tier switch, and the database tier. You have to have the routing, you have to have the load balancing, and you have to have the firewalling, which are the dashed lines around the entire app as well as between the tiers of the apps. So with the true SDDC and NSX integrated, you can create this entire application and software. So you get not just the VM placements and spinning up of those VMs, but you get the wiring to each other on different tiers, as well as security and availability through the load balancing. Okay. So I'm going to hand it over to Becky here for a bit, and then switch back.
We'll go back and forth, try to keep you guys awake. I appreciate you guys staying around for this last session of the day. So on the VRA side, how many of you guys are utilizing VRA today? Okay, a few in the audience. Okay, how many are evaluating it? A few more. Okay, great. And you guys have been to previous sessions on VRA? Okay, so about the same with NSX. So we'll keep this quick and we'll get to the exciting stuff. So from a VRA perspective, as Andrew mentioned, right, it's really about automating. It's automating IT, allowing you to automate your tasks, automate your delivery of your IT services. When we look at this, what we're really talking about is you could be anywhere in this spectrum, right? So we have some customers who are still manually provisioning, others who are further over here. Maybe you're fully virtualized, maybe you still have some physical out there. You've got manual approvals, or maybe you actually have like a service desk, a change approval type of system in play. What kind of governance do you have? Is it highly governed or not? How standardized are you on the technology stack below? And then, is it homogeneous and all vSphere, we hope, but in reality, we know enterprise-wide, there's a lot of heterogeneous out there. So from the VMware perspective, and especially the management suites BU, we understand that it's not all VMware. And so we're going to support your overall enterprise environment, right? So we're going to help you manage and automate on top of that heterogeneous environment you've got out there. Obviously, very tight integrations with the VMware products like NSX. But anywhere that you may be on this spectrum, we can help you start to get efficiencies, right? Help you automate those tasks and deliver the things faster, deliver service to the business, get more agile with that. So that's really the goal with VRA. And we start with automating the infrastructure as a service and then move up into the middleware, database as a service, and then all the way up and into your application stack and DevOps. So when you look at VRA's policy management, you have this idea of these business groups. It's the way you organize your users, right? Different groups, maybe by line of business, maybe developers versus testers. Depends on how you want to organize your environment. But this helps us determine who gets to provision what where. So then you map in all your resources, and again, virtual, physical, cloud, public cloud, bring those in, and in VRA, you actually put those into what we call reservations, right? So you're able to basically break up your different environments for different purposes. So you can have different sets of compute resources all in the same virtual infrastructure, but carve out, here's what finance gets, and here's what HR gets, and here's what development gets. And maybe you have different SLAs for those environments, right? For production's obviously going to have a higher SLA. So it allows you to carve up the resources into these groups, into the reservations, and then assign them to the business group. So this is where you map the resources to the people. What and who, right? So then we take a look at how do I actually define what I'm providing, right? I've got a blueprint that models a machine, models an application. Let me write that and then say this group of users is entitled to this blueprint and this service. And then when they request it, here's where it gets deployed. But it's not just that initial provisioning, it's actually throughout the whole life cycle. And we have an approval process as well, right? So not only are they entitled to it, but when they request it, send the request to their manager, make sure the manager approves it before you go ahead and provision, right? So it's more about that life cycle management, the governance, and policy around the way IT delivers services to their end consumers. And doing this with a self-service catalog, so the user can log directly in and make the request instead of IT having, to get the ticket and wait to set that up. So that's kind of just a brief overview on VRA. Looking at VRA and NSX together, as Andrew mentioned earlier, right? Traditionally, you're talking days and weeks for configuring. If we hone in on this automation process and just focus on the network and security tasks, what do we hear from customers? Today, they've got to open a ticket for connectivity, right? Make sure everything gets connected up, get the VLAN created. That's one process and step. Assigning IPs, this could take weeks. Get the router configuration correct and the protocol set up. Get the firewall set up, another task, right? The security team maybe gets another 3 weeks, right, to actually deliver the security for the VM. And then finally, if you need load balancing, that's yet an additional thing that you're waiting on. So it's not that any one of these tasks takes days or weeks to complete in and of itself. It's the fact that you've got different teams with different SLAs, and they're manually configuring these things. So I've talked to customers where this process takes 10 weeks, only because of the time they have. I've got 2 weeks to accept the ticket and another 2 weeks to actually implement what that ticket requested for each one of those teams. So from a VRA perspective, we want to help you automate all of those tasks and do these with NSX. So we're going to take that same application that Andrew was showing before, and from a VRA perspective, you can now, when the VMs get provisioned, automatically connect them to existing networks, if you've already preset up those networks, or do on-demand networking, meaning VRA actually tells NSX, build me an on-demand logical switch with this type of configuration, and then connect the VMs to it. That switch is now dedicated to that tier of the application in the environment, and it's got a router that's then connected out to the rest of the network. And so you can do this for routing and NAT type of networks, where you want to have that external connectivity, but you don't want to have to pre-build all of the network tiers ahead of time for each of the applications you're looking to deploy. Then I can do security. And again, as Andrew mentioned, you can do security at the VNIC level here. So I can ensure that the way these two VMs communicate to each other, I have control over, and how they communicate out to the rest of the application and to the rest of the environment. And being able to do that at the NIC level of the VM and in the ESX hypervisor. So I no longer have to rely on a perimeter physical firewall or even a perimeter virtual firewall that's sitting way out here in the data center to let me know whether this VM can talk to that VM. They're sitting on the same host. The host has the tables. He reads it, says go. So it's line rate firewall, right? Distributed firewall capabilities. VRA can then make sure that in the blueprint you're assigning what that security container should be for those VMs. So you can do join existing security groups, you can set security tags, or you can even build on-demand security groups. Where again, from a VRA perspective, you say, the group doesn't exist, but my security admin has built me the policies. I know this type of application needs this kind of connectivity. let me pick those policies, and when VRA deploys this application, it'll tell NSX, there'll be a new security group, assign these pre-approved policies, and add these VMs to it. And then finally, load balancing. So you can utilize NSX to do dynamic load balancing and have dedicated load balancers for this application. So instead of having to worry about using a centralized load balancer, which you can still do, but in the centralized case, now when you do maintenance, you're affecting a lot of applications. By distributing the load balancing and having dedicated for the application, you're able to use that virtual service in NSX to load balance this application. And we build all these, the connectivity and the security and the load balancing on demand. So when we go to destroy this application and tear it down, we'll actually clean up those configurations in NSX as well. And we'll talk more about that. And at the end of the day, it gets you the ability to make sure you have the appropriate networking security for the application with the right performance. So when we look at VRA, you're in a blueprint, right? So what do? You define once and reuse, right? Standardization, making sure you're getting consistency in the way that these applications and the machines are deployed. You've got options for the end user. So at request time, you can customize and give the ability for users to provide data and say, you know, I need this tweaked, right? I need a few more of these, or I want to increase the memory. And then again, it can go through an approval process. So make sure that that request is okay, approve it, and then carry on with the deployment. We support multiple different network topologies. We'll get into that a little bit later. Again, repeatable deployments, and anywhere from a single machine all the way up to multi-tier applications. Once you've built your blueprint, you want to publish that to your catalog so you can provide a one-click deployment to your end consumers. Now, some of our customers, IT is still the consumer in the catalog, but everything's been predefined. They can just click that button, fill in some information, and they're off and running. In other cases, that consumer is the end developer or other users within the line of business. You order your application, and now with NSX, you're getting your full network and security configuration with the applications and with the workloads. So it's not a matter of, okay, I've got the VM up, no big deal. It's easy to get a VM spun up, but you don't have all that wait time on the network and security config. Now it's all automated and done with the request. And this is done via NSX APIs for the on-demand stuff we build out. VRA also provides IP addressing capabilities. So VRA can do basic IPAM for you, and then we can also integrate with external IPAM solutions like your Infoblox, Blue Cats of the world. And the automatic cleanup, which I mentioned before, right, is when you decide to destroy that deployment, it's going to clean up all those configurations. No longer are you stuck with these firewall rules that stay around forever for machines that are gone because you're too afraid to delete that rule because you don't know if it's going to make you vulnerable. VRA tells NSX, remove these configurations because now the VMs themselves are gone. So it simply looks like you've got a catalog item, you click that request button, and inside that request, in that catalog item, it's mapped to a blueprint that includes your connectivity, your default gateways, your network profiles, DNS information, any of your security configuration that you need, and the load balancer. So with that, I'm going to hand it back over to Andrew to go over some of the key use cases, and then we'll get into demo.
Okay, so we define sort of three ways you can deploy an application with networking security from VRA. And so these are our three main use cases. And there we go, okay. So the first one is where everything is on demand. So this is all the different object types, your switches, your routers, your firewalls, and your load balancing are all built when the user clicks on the catalog item and wants the application. So everything is built on demand, and when the application's life cycle ends, everything is automatically cleaned up. And that's sort of the best way to use the two products together because things come and go as they're needed by the cloud users. We have a hybrid model of where security comes and goes on demand, but it sits on top of pre-created networks and pre-created routing and switching components. And then we have a setup where you can deploy virtual machines on top of completely pre-created stuff that the NSX admin makes, switches, routers, load balancers, and firewalls. So everything's made in advance, and then VMs land on top of those. So I'm going to go through all these. I'm going to start with the on-demand, and then we'll go from there to sort of the less interesting, in my opinion, but alternative ways to do this. So here's an application that we want to build. This is WordPress. You have 2 VMs running as a web and app tier. It's, since it's, the web and app are on the same machines, it's only a 2-tiered app. So they're running, it's a Linux machine running Apache and PHP, and then you have a database machine running MySQL on the database tier. So what NSX and VRA will do is we will build this entire application, and all the components will be built on demand. So the VMs will be either cloned or copied, and then they will be placed on logical switches that are made from VRA through the NSX API. It'll have a load balancer and a router. The only thing that's pre-created in this is, the pointer doesn't quite do it, is this upstream grayed out router. So that might be a physical router in your physical infrastructure that is the next hop gateway from the dynamically created router that's in the application. So ultimately, this is a nice solution because, oh, and I forgot, all the firewall rules are created. The purple dashed line around the perimeter is an app isolation firewall to keep that app isolated from other copies of the same app. And then the blue and the orange are to isolate different tiers from each other. We also can isolate on the same segment traffic between the web VMs. So in most cases, you wouldn't want your 2 web servers to talk to each other, so we can block traffic between them, even if they're on the same switch, which is a really nice feature. Allows you to do, as Becky said, firewall rules at the per VNIC level. So in this, we support both a NATed topology or a routed topology. So the NATed topology is when this environment has its own address space, so that if another user creates another copy of the app, it will also get its own address space. So each application has its own unique address space, and we'll do NATing on the dynamically created router. The routed topology is where we will pull addresses from a IPAM database and then advertise those routed through BGP or OSPF on the dynamically created router. And that's where you need to have, you want to have each of these dynamically created subnets be propagated throughout your routing infrastructure. And as Becky mentioned, usually you can use the built-in IPAM system that's part of VRA, but you can, most customers will use integrations with the third-party IPAM solution like Infoblox. So that addressing is all automatic, so you don't have to do any manual IP addressing. So the VM, not just the VMs, but the VMs themselves and the switches and the router interfaces and the load balancing VIP, all that addressing is automated. And again, if you use a third-party IPAM system, it also will automate the DNS entries for you as well. So these security groups that contain these VMs, they're on demand as well. The VMs are, a security group is defined and a VM are placed in it, and then a pre-existing policy that's defined by your firewall admins or your security auditors will then be applied. So on the web tier, I might have a policy that says inbound port 443 only, and on the database tier, I might have a policy for inbound MySQL. So these are all automated, all these groups are dynamically created, but the policies are not. They're predefined because they're used by multiple applications. Okay, so that is the everything on demand. Oh, sorry, and the load balancer is automatically deployed, including the VIP. Okay, the second use case is where you, for some reason, decide you want to pre-create the networks in advance and pre-create the routing infrastructure, and then on top of that, apply security automatically. So it's the same application here, but the difference is that the router over on the far side is already created. That's why it's in gray. The switch is created by the NSX admin, and the load balancer, but then the load balancer and the security components come on demand when VRA requests the application be built. So this is more of a traditional approach to networking, where the networking team will pre-create something and then the sort of the server team will wire their servers into it. So this is, some customers like this because they're more comfortable with these pre-created networking components. In this case, often the IP addressing for the network is done manually, but the VMs are still dynamically addressed. The key thing here that's interesting is that the security is still done on demand, meaning that firewall rules are only created when the app is initially requested, and when the app goes away, the firewall is automatically cleaned up so that you don't have leftover firewall rules in your firewall rule table. So we call this generally micro-segmentation because multiple applications can end up sitting on the same layer 2 subnet and share the same subnet addressing space. The load balancer in this situation is also dynamic. It is spun up on demand, and then once the app goes away, it'll delete the actual load balancer. So that is you get dynamic security, but on pre-created networks. The final one is for people who like to do a lot of manual work still in the NSX UI, but then automatically deploy VMs on top of it. So in this case, everything in gray is pre-created. So here we have a pre-created router, a pre-created load balancer, a pre-created web app tier, and a pre-created database tier, as well as all the security groups are pre-created. And all that we're doing with VRA is placing those VMs onto those networks and putting them into those security groups. So everything is defined in advance by the NSX admin, and then the VRA just places VMs on those networks. So the advantage to this might be that if you have a traditional group of networking admins, they may be initially more comfortable deploying the networking stuff through manually clicking on it in the GUI and letting then VMs land on those. However, it doesn't give you full automation that you would get if you went with the first use case. We do see people sometimes start with this to get comfort level, and then they'll gradually move to the fully dynamic on-demand creation of networks and stuff. And these also can be single tier or multi-tier. In all three of these scenarios, you can have single tier and multi-tier applications. Okay, so now, So again, one interesting thing about NSX is we can build a traditional three-tiered app with three different layer 2/layer 3 subnets with a router in between, which is what people usually do in the physical world. But we can also build a multi-tiered app on one logical switch. Because our firewalling happens at the VNIC level, we can have multiple VMs sit next to each other in the same subnet, but not necessarily talk to each other, because we can do firewall rule control between those virtual machines. And we call that microsegmentation. And if you build lots of them, they can all sit on that same single large flat network. Okay, so I think we're going to now do a demo, and are you going to do live or recorded?
We're going to do live.
We're going to go live.
I got the recording in case we have trouble.
We have a recording as a backup. Let's see
as a backup. Here we go. Let's make sure the internet's still working for us.
And then we will definitely have time for questions. So.
Yeah, we'll leave time for questions. So, so this is a tech preview of the new vRealize Automation 7 release. We have one of the major things, and Andrew highlighted it earlier, was we built a new blueprinting model within vRealize Automation. And so we have this whole new design tab that you'll see here. And we've built this new blueprinting model to really simplify the way that you can define your machines and applications. So in VRA today, you have single machine and multi-machine blueprints. They're separate entities, but they work together. And then we have an app services offering, which is a separate product today, where you do the application blueprints, and it integrates with VRA. What we've done in 7 is gone to a single blueprint model, a single UI for where you define that, whether it's a basic single machine all the way up to an application blueprint. So we're actually converging our app services product into VRA. The converged blueprint model is the first place that we're doing this, and you'll see us continue to add more of those app services features to VRA as we do that. So to kind of start real quick in this designer, we've got 3 components. You've got blueprints, we've got X as a service, which is also a new name for our advanced service designer. This is where you may wrap any VRO workflow as a requestable item in the catalog and do custom day 2 actions, which there's plenty of good opportunity there with NSX. And then this new capability here around software components. And this is where, on the software component side, you can actually build out pieces of software. So let's take a look at, let's say, Apache real quick. And the reason I'm going to show this is we're going to do a true multi-tier application. So I want to show you guys these capabilities. So you give it a name, and you can even select the container in which this piece of software is allowed to be installed onto. You can set up any kind of properties you want, custom properties that can be utilized within this piece of software. And then you have actions set up. So you can set up installation scripts, configuration scripts, start scripts, and uninstall. Now this capability supports Bash on Linux, which then you can use Bash to wrap Python or Perl or something else. And on the Windows side, it supports PowerShell scripts and command. So you're able to take your software packages and integrate those now into VRA. Let's go back to the blueprints. I actually want to show you how we can build this out. So we'll start with looking at this just simple CentOS WordPress web blueprint. So what I have here is a brand new canvas. This is our new graphical canvas. And I've got a simple vSphere machine. And you set this up the same way you would a standard single machine in VRA/6.2 today. I give it, the name and information, whether or not there's any reservation policy. I want to make sure it goes onto a particular type of reservation. You can set that here. Machine prefixes, minimum, maximums. Your standard build information, in this case it's a server with a link clone and what workflow and what we're going to clone from to build it out, and any customization spec from vSphere that I might be using. CPU, memory information, storage, that's all standard. That's it. This is a pretty basic, simple machine. But what I really want to show you guys is how do we build a new multi-tier application with the NSX configuration.
So instead of having separate single machine blueprints and multi-machine blueprints like in VRA 6.2 and earlier, you now can have this combination of, you can use a blueprint within a blueprint within a blueprint. I don't know how deep you can go,
Yeah.
but you basically can layer blueprints. So you can have, she has the Apache web tier machine here, and you'll add Apache to it, and then
Yep.
she'll combine those with the other, and then the database tier.
Yep, so we'll build that all out. So one of the key things when you build a new blueprint is you can decide whether or not you're using NSX, and if you are, and you want to do on-demand networking, which we're going to do in this example, I need to select a transport zone. So I need to ensure that I set a transport zone for that. Another interesting feature here with the NSX integration is part of the NSX infrastructure where we're building out these applications and the way it's able to provide the services like the dynamic routing and the load balancing is through using NSX edges. So we're actually building edges to do those services for these applications. You can set up a reservation policy that says put all the edges, the edge VMs, into my management cluster where the application itself is going to go into other clusters in the environment.
Or a dedicated edge cluster.
Right, or a dedicated edge cluster. And then the app isolation that Andrew mentioned. If you check this box, now this application will be isolated from any other instance of the application running out in the environment.
Let me comment on the other thing. So also the routed gateway reservation pool, you can actually have multiple paths in and out of your virtual environment to your physical environment. So you might have different teams who have different access, different paths that they would go in and out. So you can choose which path that this application will take to ingress and egress from the virtual environment.
Exactly. So now we've got this blank canvas we're going to start with. So I could build those machines like you saw that vSphere machine, but I already, to Andrew's point, I've already built some blueprints. So I have some base machine blueprints, and this is where you can start to collaborate more with the different administrators and architects in your environment. So the infrastructure admin or the cloud admin may be the one who built these initial machine blueprints for me, and now I'm coming in as the app architect wanting to build the full application out, and we can share those things. So he can do some work, save it, I can come in, do work, have your security networking guys come in and sign off. So it gives you the ability to really collaborate across those silos.
And you can export them and import them, so you can
Absolutely.
run them, build them in one copy of VRA and send them to somebody else and import them back into a different version of VRA. Or you can collaborate with people across the internet and trade blueprints and things like
Absolutely. That's actually a really key new feature with 7 is this ability to do the import-export of blueprints. We export them into a YAML file format, and it's human readable, and you can actually create a blueprint just in that file format. You don't even have to use this really sexy UI, or you can build it first here and then export it out, and you've got a few that are similar and it's just a couple of quick changes. You can do that much quicker, let's say in a Notepad++, than in the UI itself. And as Andrew mentioned, then you can share them across your tenants, share with other people, and check those blueprints into your source code repository systems, and be able to ensure you've got the versioning and those blueprints now sit alongside your artifacts, your software, your code.
Anybody doing infrastructure or code type projects yet? No?
No?
Raise your hand. No? Okay. So defining your infrastructure as a code component in YAML or YAML and checking in and out of Git, any of that kind of exercise? No? Okay. Interesting.
So in this example, I've dropped on this CentOS, that's my WordPress web server, that's going to be his role. I'm going to up the instances to 2 because I want to load balance them, so I'm going to have 2 web servers here. I'm going to also now drag on my database server, okay, and again, the CentOS configuration here for my database server. So I've got those 2 components. Now I want to start to layer on the software. So we had talked about, WordPress, right? So I'm going to take and drop on Apache onto my web server. Here's the configuration for that. And then I've actually got an Apache install capability that I'm going to drop into the Apache server itself. Now you may have noticed, you see this little red, hey, you can't drop this here? When you build out the software components and you build out the artifact files that go along with your software, you say what component is supported. So this is an Apache install file. It doesn't go on a machine, but it can go into Apache itself. So that's what I'm doing in that case. And then I also need PHP, you know, that example that Andrew had, right? I need to drop in my PHP. And I can drop that right here onto the machine.
But not on Apache.
But not onto Apache. And actually, let me move him a little lower so he's stacked cleaner. There we go. On the database side, I'm going to put on MySQL, our SQL database here, a MySQL database. So I'm going to drop that again here. I've also got a SQL script, I believe. Yep. You can see it. Where's my...
WP MySQL config.
Thank you. This is my SQL script for configuring that SQL database. And again, I can't drop it out here. I can't drop it on the machine. I have to put it into a MySQL instance. So this is where I'm actually defining this two-tier application right now with the software components, the configuration files along with it. Now let's get to the NSX piece. This is where... Oh, go ahead.
So what we're not showing that's behind the scenes is the Apache prep script is probably a bash script that will build the proper Apache settings, and the MySQL script was likely a SQL script that contains all that stuff. So that's defined in another place, but that effectively, when you spin up this application, will run those prep components to make sure that the application is properly set up.
And the other thing that you can do that's really valuable here is with those prep components and the software and the scripts, you can also pass properties and bind properties across these entities. So if, for instance, Apache needed some information from the database server to do its configuration, you could actually say, get this value for this Apache property from a property on the database server, and it'll handle that all dynamically at deployment time and figure out those dependencies. Apache will then wait until the database server is configured enough to then pass that property over to it and then continue on with its installation and configuration. And you can do that across machine components, across software components, so that ability to really we call auto-bind those features or those properties amongst each other versus having to like hard code and know the values of all the things, right? And especially if it's a property that you want to ask the requester. So maybe it's a developer requesting something, and he's going to specify some information that then needs to get passed down to these scripts or to these components. You can do that. So on the NSX integration side, you'll see we have this networking and security tab. We've got existing networks you can connect to, existing security groups, on-demand load balancers, an on-demand NAT or routed network, on-demand security groups, and the ability to use existing security tags. So in this example, we're going to build an on-demand routed network, or NAT network, sorry. I can give it a name for now. I'll leave the default name for now. And then I see the available network profiles. The network profiles, again, are something you configure outside of the blueprint because you want to reuse those across blueprints. So your network profile is that definition that I mentioned earlier where it says how do we want this network to be configured so that when we call the NSX APIs, we've got that configuration information. It also includes the networking information that the VM itself needs. What's my subnet mask, my IP, where I'm getting my IPs from, those type of configurations all come from that network profile. In this case, I just have one. And when I open it up, now I get to see the details about that network profile. It's a one-to-one NAT type. I see the subnet. I see the gateway. There's DNS wins information if necessary. If I'm utilizing DHCP versus IP ranges. So you see all those capabilities here. So we're going to just do that simple network, and then I'm going to go ahead and bring in some security groups. In this case, I'm going to utilize existing security groups. This one I'm going to use for my web tier. So I have my NSX admin, Andrew here, has built me an existing web tier security group that I can utilize. And also, I can build one for my database tier.
Now, as the NSX admin, for each of these security groups, I've defined what types of traffic are allowed in and out. So maybe outbound, I'll allow NTP and DNS, and inbound for the web tier 443, and inbound for the MySQL tier, the MySQL port, which I think is 1433, so that you can predefine what the firewall rules. And not just firewall rules, we have advanced integration with IDS, IPS, and tools and antivirus tools where you can route the traffic out to those tools as well. So you can define in your blueprint that they will any traffic going in and out of the website could actually be subject to IDS inspection or something like that.
Right. And that's a great value add. And for VRA, we integrate with NSX, and that integration for us is handled through NSX security policies and the security groups. So we don't have to worry about having to integrate with each one of those different security vendors. NSX is doing that for us. And in the case where, let's say, I don't have a pre-existing security group, but I do have those existing policies, again, we're gathering this data from NSX. So we're gathering the available security groups, the security tags, and security policies. So I could have gone this way and said, you know what, I've got a web tier security policy here, and I'm going to build a new security group for that. So that's the way you would do it, almost identical. But in this case, I'm going to stick with the two existing security groups. So now I've got my basic network down for my on-demand network. I've got my security containers I want to use, but I need to connect them to the appropriate VMs. So I'm going to go back to the WordPress web VM, and I'm going to add a virtual NIC, and I'm going to pick the available network. So you notice here we're only showing you the networks that you've defined in the canvas to use. I'm going to go ahead and have it be static IP'd, and it'll pull that IP from the network profile. And from the security side, I'm going to make sure I add him to the web tier security group. Now what happened automatically on the canvas you may have noticed is I've automatically now got connectivity, shows that relationship to the network and to the security. So as you get into more complex, configurations, you can see those relationships at a glance versus having to look through tabs of configuration data to figure out what connectivity you've set up and what security you've included. So same thing on my database server, connect them to the same network there. And I could do a tiered networking, right? So I could actually add another network if I wanted to. And then here, I'm going to make sure he's part of that database tier security group. So at the end, I've got my two-tier application with its appropriate networking, its appropriate security, the software components, the installation scripts. This is the ability to deploy that complete application, right? So once I've done this, I would actually go ahead and save it and publish it, and then put it into the self-service catalog. I've already done that, so we'll kind of jump over. Here's where you can publish. Now, again, as you're collaborating, keep it unpublished, save it, come in. Once it's ready, publish it out. VRA lets you set up entitlements and approvals. So you say who is entitled to actually request that blueprint with that application we've just built, and what's the approval process for them. And not just the approval process for the entire blueprint, but let's say you've got an approval process for using a piece of software. So, MySQL or Oracle requires a license, and I need to make sure that we've got the appropriate licenses before I let developers spin up 30 of these instances. So you could have an actual approval process just on SQL Server. So any blueprint that includes SQL Server goes through this approval process.
So I want to make one interesting point is Becky built not my first use case and not really my second use case. She was able to build an in-between where some of it was on demand and some of it was pre-created. The security groups were pre-created. So there's a lot of flexibility in how you can deploy networking and security with VRA and how you choose to integrate the two products.
And then here you can see my catalog, and you got to love that I can put in that kind of a graphic representation. So one of my SEs built this demo environment, so you got to love his sense of humor. But here's where I see all my services, and a lot of these are VMs, they're applications, but they could be other services as well. And so once you publish out of the catalog, and me as this user, I'm entitled to utilize it, you'll now see I get a request form. Now you've got the overall WordPress application and some base information here. What's the description? Give a reason for your request, least request information, how many instances. And if you need to, and you want to allow the user to specify more information, they can even go down to the individual vSphere machines, increase those number of instances, add the CPU and memory, and update the storage if you allow them to. So you as the author control what they're allowed to set. Same thing on the software side. So if there were actual properties that you wanted the user to provide within the software components, those would show up. In this case, there isn't any. And you would submit it, and then it would go through the approval process, and if it got approved, it would show up in your items as running. And in this case, you'll see that's being requested. I'm going to show you one that we have already done. So you take example, here is my Apache 2.0. This is another example. We've already requested this guy. And you get the items, details, and the available actions for this component. And that one actually is not the one I wanted. My apologies. Let's go to my finance application. So here's a finance application and the properties available again, and the different types of actions I have. I can archive this, I can change the owner, I can destroy it. So you have those different capabilities when you look at the different items here. So with that, I think that's pretty much what we wanted to show.
All right, so we're going to have some time for questions, but before we do questions, can you bring the deck back up? There is a survey for these sessions, and we would appreciate it if you guys filled out the survey and gave us feedback. We do read the feedback, and we find it very valuable. So I think you can also win, is it $25 VMware Company Store gift certificate by doing it. So with that, I guess we'll go with questions. Anybody have a question?
Raise your hand. They're going to bring mics around if you guys have any questions.
I can't really see you. So.
I know. Yeah, we're getting blinded up here.
Over here.
Will there be a tool to do reverse engineering of already set up applications?
Great question. I love this question. I think I've got this question about 5 times this week. And I wish I had already built the solution because that is, it's a great question, right? So the idea is, could you just point at a brownfield application, figure out all those software components, all the dependencies, figure out the network and security config, and then make a blueprint from it? We don't have that capability. That would require some serious magic. I like the idea. I might decide to do my own little, is this being recorded?
Startup.
No, I was going to say I might decide to do my own little startup for that. So no, not to that level. It's definitely something where you'd have to, we'd have to work with you to really look at the environment and figure out that configuration and then model in a blueprint.
But you can have running VMs
that
then you can model around those running VMs. It won't automatically do it. It has to you have to give it some information of what that application looks like because it doesn't know what those VMs relationships are.
Yeah, so VRA can manage brownfield machines, and to Andrew's point, you can import those in and then associate them with a blueprint that does have a similar configuration of them, and then do additional lifecycle management of those machines. But to be able to automatically figure out all of that and do the magic, I mean, it's a beautiful idea. Now,
let us know when you figure out.
Yeah, well, or I might let you guys know next year. But there is another product within VMware Suite that is called VMware Insight Navigator. And that does at least have the ability to inspect your VMs and how they're communicating on which ports. So there are some tools that you can utilize to get a feel for how is this thing really operating, so I know how it's communicating, so I know how to build the appropriate security policies when I go to rebuild this in my environment. A great question. Any other questions?
Hi. When you're talking about NAT and about the capability to provide NAT rules, is there a likelihood that users will be able to actually go and define NAT rules for applications directly, or is everything going to have to be pre-built and you choose a pre-built policy which is available in NSX?
So currently it's effectively a pre-built policy, and we have basically a roadmap item that is, the idea is to give the user themselves more choice at deployment time or on what we call day 2 operations to add additional NATs, one-to-one NAT, port mapping, port forwarding, I mean the whole collection of that, the NAT world of all the features that people are used to in NAT device, most NAT devices. So we want to eventually expose that to end users, to cloud users, both at request time as well as on day 2, but it's not in the current shipping, and it's not in 7.
Yeah, so and it's not coming in 7. Now there are extensibilities, so if you wanted to provide that, you could write your own VRO workflow to the NSX API and then make that actually a requestable day 2 action in VRA, and then you get the approval system and the automation, but it's not out of the box. So we want to get to making it out of the box.
So we do, one interesting thing about VRA is it is incredibly extensible, which is really powerful, and you can basically do almost any of this stuff, and we do have NetApp is one customer who does this kind of day 2 NAT operations through the X as a service functionality. So there is a way to do it. What I'm referring to is out of the box. We don't yet have it as a baked in feature.
I think there's a question over here. Is there?
I think you might have answered it, but it's about day 2 operations and whether you've got like pre-built, pre-templated operations that the administrator can just amend for So it's whether you've got templates, I think. So
Of the actual actions themselves, of
say
like
if
operations?
whether a user can, if they make a mistake on their first build, or their first request, whether they can, if there's, so it's basically whether they can amend what they originally asked for. If you see.
Oh, if they can amend it, if
what
it's already deployed
different-
or
yeah, already-
before?
Would that be done by day 2 operations?
It would be done by day 2, yeah, to make
Yeah,
changes. So whether amend because they need a different configuration, or things just changed over time and you want to do that.
So it depends on the feature, yeah.
It
So we do
does.
have some day 2 operations, and some stuff is would require customization. But there are things you can do, like you can add another web server to the web tier and automatically attach it to the load balancer, therefore scale out. There are features like that.
Yeah, you can take, the user can take snapshots, they can power on, power off, do those sort of things. And then you actually, as the administrators, can control what actions they're allowed to take on those different components. So maybe some of the machines that they own, because they're running in a development environment, you let them have full access to all of those type of actions, even reconfigure and things like that. But maybe in a staging or pre-production environment or production environment, you don't allow them any of those operations, or maybe only to create a snapshot. So yeah, there's definitely flexibility there for the out-of-the-box ones. And as you build any custom operations, you don't let that end user take, you can also, again, entitle that action to the user. So just when you build a custom action, it doesn't mean every user gets to run it. So you control that.
Depends on the entitlement, yeah.
Other questions? I thought I saw some over here, but not sure. No? All right. Well, thank you guys so much for sticking around. I hope you guys had a great VMworld. We were
Thanks
so
for coming to
happy
the
have
last
you.
session. Yeah.
Exactly. We were thrilled we had this many people. So thank you guys so much. Safe travels.